Hello, everyone. My name is Butch Wesley. I am creator of a unit testing, automated testing framework called Gut. Thank you. That is way better than a glazed look in someone's eyes when they're like, "What have you done?" I'm like, "Oh, I made a unit testing framework," and they're like, "I don't know what you're talking about." A woo is amazing, so thank you very much. My name is Butch Wesley. I am also BitWes in a couple different places. Reddit, GitHub, Discord, Godot forums, whatever. BitWes is an evolution of Butch Wes, which was my original Xbox gamer tag. And Butch Wes was great until I signed into a game and somebody said, "Butt Shoes is here." It's it switched from Butch Wes. In their defense, I had gotten a little creative with the capitalization of things. But yeah, somebody was just like, "Butt Shoes is here." And I was like, all right, well, let's not do that anymore. Who am I? I am a programmer. I am a comedian. I've made $16 selling a video game I've created. $8 on 2 separate platforms, which means it's probably 3 people I know. I made a mobile game a while back. I am the creator of Gut. I am a tool creator. I really like making tools. I started making Gut because as I was working in Godot a long time ago, I was like, I work better with tests, so I'm going to start making something that I can write tests in GDScript with. And it's grown, and yeah, so now I'm here. I am evidently way better at making tools than I am video games. At least getting them out there and into people's hands. I am a test enthusiast. I really like writing tests. I'm not a zealot. I'm not here to tell you how to live your life. I'm just here to talk about stuff I like doing. I really like programming. I like tests because I can move faster with tests. Some people are like, it takes too long. Well, once you get really good at it or you enjoy it, you can move a lot faster. And so I really like that. I also like the fact that it makes you think about what you're about to do before you do it. I like that when I change my code, things turn red and tests start to fail. And I'm like, I caught a bug way before I ever would if I were play testing. Also, after I've play tested something 5 times, I'm like, I'm not doing this again. Computers are great at doing mundane, automated, or redundant tasks. And so, yes, I really like testing. What is Gut? Gut is a unit testing, or automated testing framework is probably a better way to phrase it. Because you don't have to do unit testing with it, and you do integration testing with it. I don't think I would call it GAT instead of Gut. The U in Gut is unit. You install it from the asset library, and I have extensive documentation. I have done a lot of documentation. It's so much documentation. It's taken up numerous forms. Right now, it is being hosted on Read the Docs, which is something that's, I think, happened in the last year or so. I've changed some of the automation of the generation of the documentation to actually pull from code comments. So more of that documentation is available now in the editor. So hovering over things, you can get examples and stuff like that. Who am I talking to? It's weird to know whether or not, it's hard to know who I'm going to talk to. So I'm assuming a lot of people in here are programmers. Who is familiar with test-driven development in general? All right, sweet. Okay. I am going to be able to skip some of this then. Who does TDD at work? Okay. And who uses Gut? Wow. Okay. That was weird. I saw way more hands for TDD, and I was like, holy cow, there's going to be a bunch of people in here that, nope, just two. Okay, cool. That was a roller coaster. I had the pleasure of meeting this gentleman here earlier, and I must say that it's fantastic to actually meet a person that's used a thing that you've created. That's amazing. So thanks for using Gut, the two that are here, and everyone else on the internet that's watching this. Thank you. Gut's been around for about 10 years in some form or fashion. I started in the 2.5 days of Godot, and it's grown. I've had 285 issues not made by me, and 114 pull requests, 36 releases across 3 different versions of Godot. And I've found people making YouTube videos about a thing that I created. I don't know if anybody's ever had that, but that's amazing. Like, if you made a thing that goes out and causes other things to get made, I mean, I guess that's what Godot did. But anyway, yeah, it's fantastic. So thanks to everybody who's used Gut, and thanks to all of you who are clearly going to use it as soon as you get out of this conference. Some of what I'm about to say is not entirely true. There's a lot of caveats to doing some of these tests, and some things are slightly on and off, and I'm going to simplify some things. I'm going to tell you that I do test-driven development, but I'm not going to write all of the tests live, because that's just crazy. That's crazy to try and code live for an hour. And expect any of that to turn out well. So I'm not going to do that. If you think that I've said something wrong, you're probably right. And better yet, maybe you should be right. Maybe I'm right, but you should be. So if you've got any questions or anything like that, or you think something should work a different way, or whatever, I love questions, and save them for the end, but feel free to ask as many questions as you want. I get questions when I say I've made this thing, and people are like, well, when do I test people ask, when do I test my game? And I think it's better to say when you shouldn't. And because there's a little bit of a disconnect. People are like, how am I going to test a game? It's a game. There's things running around. I got to use a controller. How am I going to test that? And sometimes you just don't. If you're making a proof of concept, if you don't know what you're doing. A game that I'm working on right now, I've made about 2 or 3 bosses for it. And I haven't written a single test for them at all, because I don't know what they're going to do. There's nothing for me to test. They have to do stuff and take action, and until I find myself in a place where it's faster for me to iterate on the design of this boss using unit tests and integration tests, I'm not going to test that. Eventually, I will get to the point where I do have tests if things start to break. One thing that is under test for these bosses is the life system and my hit boxes and my hurt boxes. Like, I've got 20 other systems that are sitting underneath these bosses, and all of those are under test. And those are way easier to iterate on when using tests as opposed to play testing. But you just got to fight the boss to find out if it's fun and stuff like that. So there's not a lot to do there at first. And you shouldn't get bogged down in it. And you're also making a game for yourself. If you ever start writing a test because you feel guilty, you're probably doing it wrong. I write a lot of those tests because I'm like, oh, I'm not doing it right. I made a tool. I should be writing tests for everything. And then I go, this is the game you're making. You should have fun. If you feel guilty about a game that you're making, maybe, try to do less of that to yourself. Yeah, and you shouldn't write tests when you don't want to. When should you write tests? Any other time, whenever you want. A lot of low-hanging fruit. to get started in testing is systems that you've got. Saving and loading is an easy mark. Figuring out what your save file is going to look like, making sure that you're loading data, setting state, and all that kind of stuff. That is real easy to do with tests. I had an undo redo mechanism in a card game I was making, and that was a good spot. And if you're making state machines, you don't necessarily have to test your individual your individual state machines that you're making. You probably want to do that to some degree, but you have to make a state machine that you're going to inherit from everywhere, and that's a great spot to start putting in tests. All right. I know I told you I wasn't going to tell you how to live your life. I also told you that some of the things I was going to say was a lie. So I am going to cover a couple things about the way I work and some good coding practices and things like that that'll make writing tests and maintaining your code a little easier, and kind of gets us on the same page. When you're writing code, single responsibility is huge, especially if you're going to try and test something. If you've got something that manages your life and how you jump, maybe you should break those things apart. Your jumps don't necessarily need to be tied to your hit points. So getting things into single responsibility for your classes and your functions is huge. Small code better, that's good words. I was going to correct that, and then I was like, no, small code better. That's fun to say. Small code better. Small files, small number of classes in your files. Pick a number and decide to stay under that. If I hit 2,000 lines in a file, my stomach hurts, right? And code smells are really stinky. Your methods should fit on one screen. If you can't see your entire method on your screen at one time, it's probably too big. If you've got an ultra-wide monitor that you've turned vertically and you can see it, that's not the same. Avoid globals, which is something everybody's going to tell you, and then they're going to talk about how great auto loads are, right? Just don't use them, or use them, but try not to. That'll make testing easier, because the more globals you have, the more auto loads you're using all over the place, the harder it is to keep state from leaking from one test to another, which then causes weird results where you've got 3 tests that fail 10% of the time. You have no idea whether or not it's a problem with your code or a problem with state or whatever, and those become very hard to track down. And that's when you quit writing tests. Red-green refactor. I talked to a lot of people just make tests. Red-green refactor is huge for me. It's stuff I've heard, and I've also found it to be true in practice. So if you're not familiar, everybody seems to be familiar with red-green. Who's not familiar? Okay, good. Red-green refactor is that you write, this is the test-driven development way of doing it. You write a test that fails first, then you write code just enough to make it pass, then you refactor your code. And that's the red, green, and the purple that's in the logo. And the idea is that by having a test fail first, you know, and then watch it go green, you know that what you've coded actually made that test pass. And this is pretty much the only way we have of testing our tests. The more you write tests, if you don't do it this way, eventually you're going to be like, my tests are getting complicated. I would like to have tests for my tests. And that's crazy, but you'll probably think it. If you watch the test go from red to green, you know you've tested something. So even if if you're writing tests after the fact, which will happen, like I said, I didn't write any tests for my bosses, but eventually I may put tests on those bosses. What I will do is I will either comment out all the code or I'll just start over and pull code in as I go so that I know the things that I want covered in tests are covered in tests. So at the very least, I will comment out the code inside of a function, put pass into the function, and watch it fail, and then uncomment it and watch it go green. And sometimes I'll comment out the code and the test will pass. And that's when you know you're not testing what you thought you were testing. Or one of the things that can happen is you may have forgotten that you are inheriting from an object that already has that method. And so you think that you haven't implemented a method on an object, and you watch the test pass, and you go, oh, that's right. I'm in the parent object's version of this method. And then you have caught some behavior early, because now you get to answer the question of whether or not you should be using Super's method or you should be using a method of your own. Another thing that happens in going and doing the red-green refactor is sometimes you find out you're already done. And that's amazing. I've done this a couple times where I quit being able to make my test fail. And I'm like, oh, I thought I had more code to write, but I don't. That's great. So yeah, red-green refactor. It's great. It's important. I highly suggest you do it. When you are testing, you should be testing behavior and not implementation. Don't test how you're doing something. Forget how your method does it. Just test what it should be doing. Don't test the framework is kind of like, you can test a timer to make sure that you've configured and created your timer the way you wanted it to, but you don't need to test the timer object to make sure that it does things every 1 second or 2 seconds, or that auto start works the way you expect it to. Just assume that the framework you've got is doing its job. So stay away from doing that. But yeah, you can test to make sure that you've configured your timer to emit a signal to time out after 2 seconds, and that it started automatically. Don't test private things. Only test public stuff. Also name your methods with underscores or something, so that you know what's supposed to be, because we don't have publics and privates here, right, in GDScript. Doesn't exist. But you can name your stuff with underscores and treat them as if they're private, and that's what you should be doing. Keep that stuff away. Only test your public-facing interface, and that will also help you not test implementation. If you find yourself wanting to call a private method in one of your tests, it's time to rethink your object and your test and try and decide maybe some of this should be exposed, or maybe I'm doing this wrong. Oops. Tests should be simple. This is a neat thing about doing test-driven development and writing tests. It gives you a lot of good excuses to write really, really crappy code. And that is fun sometimes when you really try to avoid doing it, and occasionally you're like, oh, I just get to give in to my deepest, darkest urges. Your tests should not be dry. They should be, I don't know how to pronounce it, but you will find yourself doing it over and over and over and over again. You'll create an instance, you'll set some properties, you'll call a method, you'll make an assertion. You'll create an instance, you'll set some properties, you'll call a method, you'll make an assertion. All of those things are going to happen over and over and over and over again. And you're going to look at that, and all of your good coding instincts are going to be like, this smells, I should be able to automate this a little better and have a function that does this, but no, Don't do that. Just keep copying and pasting code. You're allowed to do it in your tests. It's fun. Give into it. Let it happen. It's wonderful. You want your tests to be understandable later just by looking at them. You don't want to be hopping all over. Do that in your code. Make your code as complicated as you want it. Make all that. Your tests should be simple, because as soon as your tests start to get hard to maintain, that's when you start hating having tests. Test one thing per test, or assert one thing per test. Sometimes you'll find yourself doing certain things that, I don't know, don't feel right. I don't know. Somebody tell me if this is a bad idea afterwards. I'll write a test that verifies all my default values. And every time I do it, if I've got defaults that I want to make sure don't change over time because that's going to affect things elsewhere, I'll write a single test that creates an instance, and then I'll make like 10 assertions based off of those things. And I always feel it's bad that there's 10 asserts in one test. But I'm testing one thing, and I'm not going to make 15 instances to set these properties. But, yeah. So keep your test short. Make one assertion per test, or don't. This is hobby stuff, right? Like if we were at an enterprise conference, I would, I don't know, maybe be meaner about it, but you should be testing one thing, and you should be testing as few things as possible, usually just one, and making as few asserts as possible. Making more than one assertion per test should feel bad, but continue to do it if you want. They should be atomic, repetitive, easy to understand without any other context. So let's talk about GUT. GUT it's a unit testing framework. You can run it from Godot. You can run it from VS Code. You can run it from the command line. You can use it as a CI/CD in your CI/CD pipeline. And people have made CI/CD pipelines using GUT, which is amazing. And so if you need examples of that, you can find them out on the internet. Other people are, guarding their code from their friends and their coworkers from being pushed up to GitHub without passing all of the tests, which is amazing. We've got doubling, we've got spies. I say we, it's me. It's mostly me. Doubles, partial doubles, we can stub things to call super methods to return certain things. We can return certain things when we're past certain things. We can spy on things, making sure that methods are being called when we expect them to be called. And we'll talk more about doubles, spies, and stubbing if you're not familiar with what that is. We've got your setup and teardown greats. We've got some basic asserts and not basic asserts that we'll cover later. Okay, I think I'm just going to show off code now. I've got a bunch of slides here. But one thing that a lot of people will ask for is how am I going to watch this thing play out in time? And to do that, I have a bunch of wait methods, which you can use in conjunction with await. And so let's just look at those here. While we're in here, this is what GUT looks like. It's just a big empty box. Unless you run everything and it's still a big empty box because I didn't turn anything on. Okay, there we go. You get a tree of output over here. You also get the output that would be printed over here. You can click on stuff over here. It's going to take you to that spot in the output. It's also going to take you to that test up here. You get buttons for running your entire collection, a single script, or, of course, it doesn't work. You should be getting a button. Test wait. There you go. another button that will allow you to run just a single test. And what's neat is that when you're in some other file, those buttons don't go away. So you can hop over to another file, fix your test, run your test without having to hop back. I usually end up living in VS Code because I can see more than one file. You still can't see more than one file in Godot, right? Okay, yeah. So I'm usually over here. You can use a plugin that I've created that will allow you to run your tests through here. And yeah, there you go. I just ran a test. What was I talking about? Waiting examples. Okay. So here we go. Here is a example of waiting some number of seconds. Pretty straightforward. I call a wait. I wait seconds. If I make this 5 and then run the test, we'll sit here for 5 seconds. It's very long. There we go. We can wait idle frames or process frames. I don't know how you want to call them. There is also process frames, which is the exact same thing. It's just an alias. Process seems to be how it's referenced everywhere as far as, you know, it's the underbar process method and stuff like that. But idle frames is kind of its name. So I made 2. And then there's wait physics frames. And these all get counted in underbar. This gets counted in underbar process by gut. This will get counted in underbar physics process by gut as the test waits or runs. It is important to note that this is a new feature in 9.4.0, which isn't out yet. 9.3 whatever that's out right now just has wait frames, which only does physics frames. But now we have idle frames and a more aptly named physics frames. We can also wait on a signal. Is this better? No, this is better. And we can also, when we wait on a signal, we can give it a maximum amount of time that we want to wait. And so that means that if you don't emit the signal when you thought you would, your test just doesn't sit there for forever waiting for that signal to emit. And this is an example of testing the framework. I am testing that this timer does exactly what I thought it would. And this is also another example of me telling you lies. I said I wouldn't, that you shouldn't do this, and here's an example of doing it. So we create a new timer. We create a new timer instance. This is a memory management feature of Godot called add child cough cough. Yep. Add child auto free. And what this will do is it will add the object you pass it as a child of the test, and then it will free it after the test is finished. It also returns whatever you give it, just because it's one less line of code. So with this, it's basically 3 lines of code, 1 for add child, 1 for calling free at the end, and 1 for assigning. I forgot that there's a better example later. You could do this. This is what I mean to be showing you. There we go. It returns whatever you send it. So that way you can assign it, you can add it as a child, and you can make sure it gets freed at the end of the test. We set the time, we tell it to start, and then we call await with wait for signal. And so what will happen is this will time out, and the signal will be emitted, and will come out of this await. What's returned is whether or not the signal was detected. So that way you can then make an assertion later as to whether or not a signal was emitted. You can also just assert that a signal was emitted, given an object and a timeout, and a signal name. Or you can assert true. There's a thing that you have to do inside gut called, that's per this note, called watch signals. But you didn't have to do that here because we told it to wait for a signal, and that has an inherent watch signals. Yeah, okay. I knew eventually I would get to the point where I was glazing even over the eyes of even over the most enthusiast. We're going to fight through. Hold on, is this over 12:30 or 12:15? 12:30, right? Okay. Okay. This is a feature that was given, this should be wait. This is a feature that a user actually submitted. It takes in a predicate method and will call that method every physics frame and until it returns true. So we have this method called the foo adder, which adds 1 to foo and returns whether or not foo is 10. And so after roughly 10 frames, this will return true. And we are telling it to wait a maximum of 5 seconds. So you can also wait while in 9.4, which is the inverse of this. It will wait while the method returns true. And then we have one of my favorites, pause before teardown, which will cause the test to pause before teardown, which will allow you to see how well things interact in case you have created a test. Okay, this is also when it doesn't do that. There is an option called ignore pause. And that exists because you will forget to take pause before teardown out of your tests. And so if you are doing a CI/CD pipeline, you set this flag because people will forget to turn it off, and then you are greeted with your test just pause. So now when I run this, eventually there will be a continue button here. And so there it is. This is good if you're making an integration test and say maybe you've got 2 characters that you're going to run together and make sure that the boxes, hit boxes and hurt boxes are interacting the way you expect. And you can't get things to work the way you expect them to. Doing a pause before teardown will at least allow you to see that, oh, I've got character 1 way up here and character 2 down here, and they're just not even hitting each other. So it's just a way to kind of see what you did. And then, yeah, you'll forget to take them out, so there is an option. That is it for the waiting. All right, I'm going to get to this example, and then hopefully that'll be that. People have asked how to, it gets hard to understand how to test a thing. You're like, things are going to interact, and it's not unlike trying to test a GUI. And occasionally, you're going to want to do something similar to what I'm about to explain. I wanted to do it. I thought it was a great idea. Sorry, I'm about to tear down something we talked about earlier. Occasionally, you're going to want to move a mouse over to a button push the button and make sure that something happened when that button was pushed. I thought I wanted to do this too. And you can do that. And I will show you exactly how to do it. Test, button, test. There we go. Okay, in order to do this, first we get a reference to our scene. This is the scene that I just showed you. And I usually end up making a test can make one as a nice first test to write. I put it in there. That makes sure that I'm getting the scene that I thought I was getting, that I know how to create an instance of it. It's a good place to start. It's also a good place to start and just quit, because then later you've got a place for the rest of your tests, and you can just start filling stuff in. So let's push the button using the input sender. So we have to get, this is a inner test class. I know earlier I said keep as few classes as possible into a script. Here's another example of me lying. Make as many of these inner test classes as you want. They are great to kind of group like tests together so that you can have setup and teardown methods that don't get bloated over time because you're trying to do setup and teardown for 10 different situations. Just start grouping things together inside these inner test classes. You cannot have inner test classes inside inner test classes. If you want it, open up a feature request, but I made that decision a long time ago and everybody seems to be fine with it. Okay, so we got to get another reference to the scene because we can't get to this one. And then we've got to create an instance of the gut input sender, which is a tool that I created to allow you to send input events to various objects. You can send them to input. You can also send them to the various underbar input methods on a class or on a node. Then in our before all, we have to tell it that we want the mouse to warp. We actually want the mouse to move. So when we're testing actual input through the input singleton global, we have to move the mouse in order for things to actually get like mouse in and mouse out events and stuff like that. So we have to tell it to warp the mouse. Then in after each, because we're sending stuff to a singleton global, we have to tell it to release all and clear. And this is because if you don't do this, then if you did a button down in one test and didn't do a button up, then when you get into your next test, that button is still down as far as input is concerned. And this is another example of why we should stay away from globals as much as we can. But in this case, it's input. What are you going to do? There's ways to get around it. I can tell you about those later. Okay, so then here we are going to click the button. We create an instance of our scene. We use add child auto free. We call watch signals, which is, I guess, in the other example earlier where I mentioned you didn't have to call, I probably thought I was doing this first. Watch signals will tell Gut to watch all the signals that a particular object emits and keeps track of those and the parameters that have gone to them. So you can make assertions and inspect whether or not a signal came out when you expected it to with the right parameters. We are then going to wait one idle frame so that ready has a chance to kick in and everything gets connected. Then we are going to use the sender to send a mouse left click at. And because I wanted this test to work even if I moved the start button, I made the start button public on my scene, and I just moved the mouse just a little off top right or top left corner, just 1010 over. And this mouse left click at is a nice little thing that sender will do, which will the input sender will do, which will move the mouse to that location, do a mouse down, wait a certain amount of time, do a mouse up, and that will cause a pressed event to happen. We then have to wait for all of that to play out, so we have to do another await here and wait for the sender to be idle. Then, at the end of that, we can assert that the signal that we expected to happen when the start button was pressed actually happened, and there we go. Yeah, that's ugly. That's right. Like that. This is a good example of when you get to the end of it, when you start thinking about how's it going to be to test a game, and you're like, oh, I'm going to have to do a bunch of this kind of stuff, and it's going to take 5 minutes for each test to run because I got to wait a certain amount of time for all that time. Yeah, that's it. Sorry, guys. There's other ways. I would argue that what you really want to do is you have a thing that has a start game method. You expect that start game method to emit a signal that the game has started. And so that method should be public, and you should be doing as much unit testing against that start game method. Then, maybe later in an integration test, you will want to make the button emit the signal and verify that start game was called. Not even that the signal was emitted, because as far as your button's concerned, it doesn't want to emit a signal. It wants to call start game. Start game does the signal emitting. Go test that all on its own. And nice, quick, fast unit tests that don't have to wait for anything. It's really great. So here is an example of asserting that our start game method emits the game started signal. Add child auto free, watch signals, call start game, assert that the signal was emitted. Then we get down here, and we are testing that we called start game. And we're using something called a partial double. Is anybody familiar with doubling, mocking, making test objects? Familiar? Okay. For those of you who aren't, what this is doing is I'm passing it a reference to a scene. It's giving me back an object that basically is the exact same. I've inherited what Gut does under the covers is it inherits from that object and then implements its own version of all the public-facing methods, even the private-facing, or even the private methods, because we don't really have any private methods. And it wraps calls inside there. And this is how we are able to spy on things and say, hey, was this called? Because Gut has taken over all of the methods. A double, by default, does nothing. And you can tell it, hey, instead of doing nothing, I would like you to call super. Or you can say, hey, instead of doing nothing, I want you to give me back a 12. And so you can test how you use an object in another object and not have to worry about the implementation. In this case, we did a partial double, which does everything by default, but we can sub it to do nothing, which is what we do on the next line. We tell that double of the button scene, when you call start game, don't do anything. So now we don't really care whether or not the start game does anything at all. We actually don't even want to be bogged down with that in this test. We then, because earlier we decided having the start button public was fine, we kept it public. And instead of trying to click on the button and check that signal and wait for that signal to happen, we just make the signal happen. We just tell it to emit the signal. And now we've tested up our wiring without ever having to actually touch the mouse or do anything crazy or await at all. And then we can just assert on this partial double, using the instance of this partial double that we created, that a certain method was called. And so that is a slightly more direct approach. Now, are you going to still want to move the mouse around and do a bunch of stuff? Yes, you're going to want to make sure that, sometimes you're going to want to make sure that your input's actually getting where it wants to be. And that something's not blocking your input and stuff like that. Those are kind of edge cases. But this felt a lot similar to some of the concerns people would have when they were talking about testing game. How do I do it? Why would it? And I think if you take a step back and start to abstract things away and start making methods, that do certain things, you can get to your logic quickly without having to worry about making two things interact. Do I care? Do I really want to test making a bullet move until it runs into somebody and making sure that they've lost health? No, maybe I make a method that says take damage from, and I give it an instance of an object. Maybe I make unit tests that verify that all of my collision shapes have the expected collision layers and masks. And then maybe I cover my ass a little bit later with a bunch of spot checks to make sure that things move and collide the way I expect them to. But a lot of that's going to come out in play testing that you have to do. And those kind of tests only really become important when you're trying to replicate a bug. Because you're going to move faster in a lot of cases if you're not unit testing those things. But later, when you need to have a bug fixed and you're having a hard time replicating it, starting to write those tests are good. And that's where having a single file that just has a reference to that scene, and test can make one, comes in handy. Because when you're like, hey, all right, I got to test this object now. I wasn't writing them. You already have a test. It's already out there. You know it runs. You got a home for your tests. Click a button, 1, 2, and 3. That's what we just talked about. It is 12:16. I am going to say thank you and open the floor to any questions if anybody has some. I have been Butch Wesley, BitWes. You can find Gut out there on GitHub. The extensions on GitHub, both of them are available in the ones in the asset market and the asset library. The other can be installed through VS Code. And read the docs is the current location for the help. I would encourage you to take a look at the help. I've put a great deal of work into the help, and it's pretty good. And like I said, here is, where's that? Gut test. Here's code documentation generated from code comments that has all of the asserts and all of the things listed. So most of the actual files, the help files that are out here, cover concepts and how to do things, whereas the code for syntax or the documentation for syntax and everything else is starting to live inside of these class reference things. So if you have a question, please come over to the mic. That way that they can pick up the question on the mic and it makes its way out and everybody else can hear you. There is somebody currently coming up here to ask a question. Yes? Okay. So sit still.
Hello. This is working? Hi, I'm one of the two people who raised his hand.
Yeah.
I'm glad you brought up UI testing and CI/CD testing. Those
Yep.
are like the two main things that I wanted from Gut. And one of the things I ran into previously was with unit tests, trying to run them headless had some issues.
I did forget to mention that. Yeah, keep
So
going.
I wanted to ask
Yep.
if anything had changed with that.
No, and that is a side effect of the engine. As a matter of fact, I can show you. I'll lose too much time. Sending input to the input singleton inside your unit test will not run inside headless mode because there is not a mouse in headless mode. Just doesn't exist. There are, Gut does have a feature where you can implement a method called should skip script. Yes. If you put this method in there, you can actually, if you put this method inside of your test script and return either true or a string, then it will skip that script. And so this will allow you to skip your GUI input test when running your CI/CD pipeline. And there's doing it there. Also, another useful place for using this I found is if you have a test that actually causes an error and you're running in debug mode, then Godot's going to stop on that line. But you might not want that to happen. So you can say, hey, skip this script if we're running with the debug flag, because I don't feel like having to restart things every time or telling it to continue. So yeah, I think the UI stuff is really just it's a symptom of the engine, and I'm not sure if there is anything that can be done. And this was a workaround that was created.
All right.
So
Thank you.
yeah, thanks.
Hi, great
Hi.
tool, by the way. Already feel guilty for not using it.
Perfect. You get yeah.
Kind of a narrow question, but right now what I do is I use the native assertions peppered in my code. So let's say if I'm making a button, I'll assert that the text is not empty. If I start writing gut tests, let's say I can make one, should I move that assertion into my unit test, or is it healthy to have a balance of?
I don't know. It's probably fine to leave them in there. I started making tests because, I didn't want to I wanted clear output when that happened, and I wanted to be able to run a test suite and, all that kind of stuff. I would say leave them in there. They're not hurting anything.
Right.
I don't think they do anything when you've exported.
No.
Like, I don't even think they're there when you export.
Right.
So, I would say at least leave them in there.
Mm-hmm.
Maybe you stop making new ones
Right.
because you find yourself not needing them. Or maybe you do both, and if you end up doing both, let me know why. Because that would be, I would love to know how that's useful and how that's helped.
Yeah.
So,
Sounds
yeah.
good. All right, thank you.
Yep. Hello.
Yeah, thank you for the talk.
Yeah.
I'm working on an online multiplayer game, and I wanted to ask your advice of areas for testing when it came to working with multiplayer, or online at least.
I have not done that much multiplayer work. I've done a little bit with Unity, but I haven't done anything in Godot. And that was for like a course I was teaching. So I wasn't going to overload people. I wasn't going to teach people how to unit test and do Unity multiplayer. So I'm not 100% sure exactly where it all fits in, because some of my original, if you're making RPC calls, you can stub out your RPC calls and make sure that you're responding to things the way you expect to be responding to them. So that's an easy mark. Depending on what framework you're using, I know that there's a couple multiplayer frameworks that are out there that do the authoritative thing, and you're coding for both things in the same place. This is probably showing how little multiplayer experience I have. I should know more, but nobody's opened bugs and I haven't made a multiplayer game. So I would encourage you to see if you can't find a home, and if there's anything that you would like to see in Gut, open up an issue and we'll get it in there, and maybe next year I'll be talking about how to test multiplayer games.
All right, so thank you very much. I think RPCs is a good place to start.
Yeah. That actually did come up, and there is search the help for RPCs, because there are some issues with Godot and methods that take variant parameters, because I can't get a list of the parameters that a variant method has. When you're stubbing something or trying to make something else happen, you have to tell Gut, this is how many parameters I plan on using, so that when it creates stubs for things, it can do it. So, yeah. Yep. Good luck.
Hi.
Hi.
Thanks again for the talk. This was really great.
Thank you.
You mentioned earlier about you don't write your unit test for proof of concepts, but I would say, in my experience, it's not so uncommon that you write a proof of concept and now that's the thing you're actually working on. And in your experience, when have you found that you need to start writing the test, and how do you approach the fact that you had a mess of code now that you now need to maybe wrangle?
Yeah. A lot of times, what I'll do, because most of the game development that I do, I'm by myself. I'm solo dev. And so I'll do what I think I need to feel comfortable. So if I've got a bunch of stuff that's pretty much working, there is that little back of my head thing that's going to say, hey, we should have as much coverage as possible and know that everything's working. But at the same time, I'm doing game dev in my spare time, and I'm like, well, no, I'm just going to test what I need to test to move faster. And sometimes I regret that decision, and I end up having to go back and put tests back in. The more I do, for the entire time that I've done test-driven development, the more I don't test, the more I regret it. And that just seems to be true, even though I test more, and so most of the time I am testing. There are still times when I don't test, and there are still times when I don't test that I regret not testing. So sometimes you can't avoid it, though. Like, there's been numerous times where I get and I go, yeah, I wish I had written these tests. Was I ever going to write those tests? No. Would it have been a wasted effort in some cases? Yes, because I completely changed how something worked before. Yeah. So.
Thank you.
Yep.
Hi, I'm the other God user.
Yes.
First, thank you. I use it, and it allows me to do things like big refactors that otherwise would terrify me.
Yes.
Instead, I'm like, oh, if the test pass, this works, right?
Yep.
I just wanted, in my experience also, something that I found out when I started using God is that I was leaking a lot of memory.
Yes.
And I think just like, even if you don't intend to use God for much else, instantiating everything, I think it helped me. Not sure if you found out the same, but.
Yes. Yeah, there are some, I mentioned the add child auto free. What'll happen is if you free an object and you create an orphan, Gut will detect that an orphan was created. It can't tell you much more than there was an orphan created, but it does help you find leaks, which is why I added add child auto free, because I was like, it's easier for me to find actual leaks instead of the leaks that my tests are making if I have tools that allow me to not make orphans and to free objects as I'm doing tests. So yes, finding orphans. Also, if you don't care about orphans, you can turn it off. You can just be like, hide the orphans. So God will quit yelling at you, because yeah, there's a couple cases where I'm like, I don't really care that I'm making. Gut, I think in some cases used to make orphans, but those orphans didn't show up until you quit. So there wasn't anything that I really cared about. Like, it would create an orphan or two while you were running your tests, but those were all gone.
Yeah, sometimes I get one orphan and I'm like, oh, that's fine. But
Yeah.
sometimes it's like, oh, 80?
Yeah.
Like, what's happening? And I'm like, oh, yeah, clearly, you can get them.
Yep.
I'm fair notes.
Yeah, thank you for your tool. I use it a little bit, and I'm just trying to learn a little bit more about
Yeah,
how to
thank you.
integrate my game. I think it's really great. Thank you for the talk as well. One question I had is, how do you feel that testing a game differs from testing software? I work a day job as a software developer, so you do get these a lot of philosophy things like the right-green refactor and that kind of stuff. So it's like when you're testing a video game, there's a lot more interactivity with it. So it's like, and you also have real-time things that happen that software typically doesn't.
Yeah.
How do you feel they're different in philosophy?
For the most part, as I'm working, I try to kind of suss all that out, tease that out, so that I can stay away from testing those things. But in my test, I still end up with a lot of awaits where I'm just waiting for a couple things to happen. And so it's not unlike testing asynchronous applications, because you have a lot of that kind of stuff, and that can be a headache. But I haven't really found too many places where it's in general that much different. Specifically, yes, we're testing hitboxes instead of waiting for a response from a server, or waiting for two things to run into each other instead of some kind of asynchronous event that we're trying to do. But it still feels the same. Yeah.
Yeah, I think you have to get creative sometimes when you're testing, not try to
Yeah.
run your game and then test for things, but like you have to kind of isolate interactions.
Finding problems and then creating tests is a great way to get to those more nuanced scenarios where you're like, oh, I need to replicate this bug. One bug that I created something that's not, it might be public. If it is, I don't know if I could tell you to use it or not, but it was an input recorder that would record input, and then I could then send that back into the input mocker or input sender. And that ended up allowing me to replicate a bug that I was having with a jump, where if I pushed left and jump at the same time, the jump was higher. So that was weird. And I would see it every once in a while when I was playing testing my game. But yeah, that's an example of, you're not jumping higher in a lot of other software.
Yeah, thank you very much.
Thank you. All right, I think we're over. Thanks everybody for coming out. I appreciate it.